remainder coming out of it, then.
Oh, subtract them and see if they're equal?
Yeah.
That's not a bad idea. Or we could add them together and divide by 2 and see if we get back to where we came from. Or we could look at the numerators and see if they're the same, and look at the denominators and see if they're the same.
Oh, we can do equal.
But what about if we had 1/2 and 2/4?
Our object should already self-adjust.
Exactly right. Did everybody hear that? They must be stored in reduced form, so they would never have 1/2 and 2/4. Does that make sense? Now, why can't we just like divide 1 by 2 and compare it to 3 to, or divide it by, divide them and compare it?
Decimal?
What's that?
What is decimal? I don't know.
It'd be a decimal answer. What would be wrong with that?
Are we dealing with int?
Well, we could cast it to a float and do the division. What would be wrong with that?
With division?
Yeah. If we just like divided, we did the division on one side and did the division on the other side and then compared the answers.
You're flipping one of the fractions.
What's that?
You're flipping one of the fractions.
No, not, we divided the numerator by the denominator on both sides. So if we had 1/2, we would, 1/2, we would get 0.5, and if we had 3/4, we'd get 0.75. Wouldn't that work? The answer is that one would work, but there's such a thing as round-off error. Now, I want you to know that when I was at your place in your career here, I didn't believe it. I just plain did not believe it. Oh, sure, I suppose there could be round-off error, but how often could that come up? And then in graduate school, I was writing a program to calculate a graphic scene. And when this is quite complicated, it's not complicated math, but there's a lot of it involved. A lot of trigonometry, a lot of geometry going on. And one of the things you have to do is you have to calculate what are called specular highlights. And a specular highlight is when you see a light reflected in something. So if you look around, you might see, well, I don't know if there are any in here or not. I can see a specular highlight off of that window on this desktop. They're not always shiny, but it's the equivalent of seeing it in a mirror. Does that make sense? And the way you do that is you calculate the angle from the eye to the thing bounced back to the light, and if it's in a certain range, then you can see it, and otherwise, it's got the angle, and you're calculating all the angles. And I was doing all this, and it wasn't working. I wasn't getting any specular highlights, and I couldn't figure it out. Some problem in my code someplace, I'm sure. Went through, checked, you're talking about pages and pages and pages of code. Going through there, trying to figure out what's going on. Why isn't it working? And finally figured out it was round-off error, because I was using floats, and I changed to doubles, and it was fine. All I did is just change all my floats to doubles, and there it was. It was being caused by round-off error. Now, the nice thing about rational numbers is they're exact. The ratio 1 to 3 is exact. What do we know about the decimal? I was going to say equivalent, but what do we know about the attempt to make a decimal equivalent?
It's a run-on.
You can't.
Yeah, it's a repeating.
You can't.
That's
Not exactly. So that's what's wrong with doing that kind of division. So I'm going to suggest, I kind of like that.